Most people understand that you can take a project off-grid, like a shed or a cabin, and they understand that you can take your whole house off-grid. But what most people don't realize is that there's actually a middle ground. The common thought when going off-grid is to disconnect your entire home from the utility company, take full control of your electricity, and potentially eliminate your bill. And while that is absolutely possible, it's not the only option. There are ways to limit your dependence on the grid without building a huge solar system. And depending on your goals, that might be all you need. Welcome back to the lab where our opinions cannot be bought. Now, there are many ways to have backup power and energy independence, but one approach that we think deserves more attention is taking a section of your home off-grid. And that's exactly what we've done here at the lab. While the rest of our house is connected to the grid as normal, our garage runs on its own separate solar and battery system. And for us, it has become one of the most practical uses for solar we have ever built. Our garage is where we spend a lot of our time testing and filming, and because of where we live, we deal with both very hot summers and very cold winters. So we're constantly pumping either AC or heat, and that's why we've dedicated this entire corner of our garage to running this mini split. We have a EG4 off-grid 6000 XP inverter, and then we have over here our cabinet full of EG4 server rack batteries. We have 6 EG4 server rack batteries in here, and that's roughly 30 kilowatts of storage. Then over here, we have our breaker panel. Then we have regular house outlets, and this is all wired into our inverter. So these two things are not a part of the system. How it works is it just goes, the batteries come into the inverter with these cables, they go out, up into this breaker, which power these loads. So anything we plug in, like this light, is running purely off batteries. Now this is our mini split. So this comes down here, all behind, and pops in right through this hole, which goes outside. So our mini split is running completely off grid. However, the way we've set this up, we can actually pull from the grid if we decide to. So let's say we get a lot of snow and it covers our solar array out back. Well, we still need to heat this garage so we can continue to work. Once we've chewed through all these batteries, we can then grab our grid connection from the inverter and plug into our house. That's a 50 amp tied into the main house breaker. So even though this is an off-grid inverter, it does have a grid input. We've wired it directly into the grid port to supply power when we need to. So we can just flick it on or off depending if we want to be pulling or if we just want to be using solar. These two are your positive and your negative battery wires that are coming from the EG4 cabinet. 2 sets of solar array cables. Then we have our load connection. So this white wire again is going to the breaker and then through the house plugs. Lastly, we have our grid connection. This is going behind the toolbox right to here. So again, if we want to use grid instead of solar, or we can't use solar, let's say our panel array is covered with snow and we have no other option, then we would just plug this in. Now, this grid connection that goes into our inverter does not need to be connected to the grid. It could be plugged into a gas generator or a power station. So let's say you're in a cabin or somewhere that you don't actually have grid, you could still run this system alternatively. So now I'll show you guys, if this is not plugged in, meaning this system is not tied to the grid, I will turn off the battery breaker and the light goes off. And you can see the light is connected to these outputs. Now, this is not the cleanest looking setup. However, it is fully off-grid, it is nicely placed, it gets the job done, and it just shows you what you could do if you were trying to take a space in your home or your own garage off-grid. We have it set up like this because we move things frequently. We test different products. You guys are probably making fun of us of how it looks, which we understand, but for us, it makes the most sense because this is not a permanent installation. For you, you could probably use conduit or make it look a lot less of an eyesore. And we've also done this multiple times. I'll show you on this side of the garage. Same idea, it's just meant for bigger loads. We have 50 amp plugs along with the regular house plugs. We also have our inlet box. So you can either put a regular generator, you could use a power station, or we've actually cut our cable so that one end can go into the inverter and the other one goes into our inlet box. So again, it's just like the other side of the garage. These are now our loads. So anything we plug into these, either the 50 amp or the regular household plugs, they will be powering whatever we plug into them. One other difference to this setup compared to the one that I showed you first is this doesn't have grid ties. So we have no port like there is on that side. We could run an extension cord, but like we said, this is for higher loads and we typically tie it into inverters. You could also unscrew this board and bring this anywhere and you technically have an off-grid setup. We've actually just painted this white to match, but it's literally plywood. So the point I'm trying to make here is that yes, it is not the prettiest thing, but it is very beneficial and it might be something that will benefit you. There are many advantages of why we do this and why you could do it too. And one would be reliability. Let's say that we have a power outage and we still want to film and test here at the solar lab. We can still have heat and we still can have AC just to keep it comfortable in here. We can also plug all of our lights and our gear into these plugs and keep them running. Plus, because of our batteries, let's say we had a power outage for say a few days, we can still test and still film out here while everyone else is running a generator. You also don't have to build yourself in a little corner or a box like this. We could run an extension cord through our house to a fridge during an outage or whatever else in the lab needs power. Another advantage to this is peak shaving. And what that is just banking power in these batteries during low peak rates, for example, like overnight, and then using it or deploying that energy during high peak rates, like during the day. So if you live in a place that has high peak rates, like during the day, you can be using cheaper electricity for those times. And lastly, the most obvious is that we're less dependent on the grid. So we're actually lowering our utility bill by using solar to heat this garage, cool this garage, run our lights, charging power stations, charging up our camera equipment. You can imagine we go through a ton of electricity here, so it does decrease our bill a little bit and it is worth it for us. So maybe for you, it isn't a garage, but once you start thinking about powering a specific place, the possibilities start to open up. Maybe it's a home office where you need reliable power to keep working during outages. It could keep your lights on, your computer running, and your printer and Wi-Fi online. Most of these UPS systems work so fast that you wouldn't even know if the power went out if the rest of your house wasn't connected to the grid. For a home office, you might not need to go solar. A power station might be the perfect solution. Here at the lab, all of our office spaces have power stations to run our gear. We can keep the lights on with them, we can charge our batteries, they keep our computers on and our Wi-Fi router, we charge all our camera gear from them, and we could connect lights to them if we had the power go out. So we could still have a functional room. We can charge the power stations with solar or from the grid, depending on the season if we don't have a lot of sun in the winter. Either way, you don't necessarily need a full solar system to make this happen. Another practical space could be a detached workshop where you run a bunch of tools and equipment. Think of a machine shop where you have maybe a lathe or a mill or a woodworking shop where you would have table saws and planers. Typically, people here would be running higher loads. These are things that can spike your power usage. And again, if you're using this equipment during high rate times, it's gonna cost you more. So if you size your system right, you could be running all this off your batteries. Then there are also more lifestyle-based scenarios. It could be either a home gym, a studio, or a gaming room. These rooms typically don't have high power demand, but they're often used consistently. So having lighting, fans, or computer equipment that run independent from the grid makes the space feel reliable. We have even seen people run home aquariums on dedicated backup solar systems, just so your filtration and your temperature controls never shut off. The key thing here is to know that you don't need anything close to our setup here at the lab to get you started. One of the biggest advantages to taking just a section of your house off grid is that you can start small. You don't have to spend a ton of money and build a massive system. Maybe you just need a small power station and a few solar panels. Then as your needs grow, you can expand the system over time. You could add more solar, add more battery capacity. And since you're building a system for a specific space and specific loads, it typically means a more simple install. It'll have fewer components and it's easier to wrap your head around if you're just starting out. And while none of this is free, it's still cheaper than going fully off grid from the get-go. And at the end of the day, whether it's it's worth it depends on your situation, your electricity rates, how much power that space uses, how often you lose power, and finally, how much you value being energy independent. But for a lot of people, taking one area off grid could be a much more realistic starting point. And if you're trying to figure out whether something like this makes sense for you, we've put together a few resources in the description below. We have a video showing you how to figure out a rough estimate of how much solar will save you, which is basically looking at your return on your investment. We have a playlist showing you how to size your solar system, and full reviews on power stations and solar gear with discount codes to try and save you guys as much money as possible. But that's pretty much all we have for you today. If you do have questions, make sure to leave them in the comments and we'll try to get back to them. Otherwise, please subscribe if you haven't already. Thank you for watching. We'll catch you in the next one. Peace out and stay charged.